I'm going to take a look at how some other graphic organisers can be utilised to help organise our ideas and support this active revision. So we're going to look at using Venn diagrams to compare and contrast, and also how we could use storyboards or flow diagrams to show our sequences and thought processes. So we're going to take a look at how our structures and bonding of graphite is similar and different to diamond. So this is going to be using a Venn diagram to compare and to contrast our structures and bonding of graphite and diamond, and this can be really useful for 6-mark questions where we're being asked to compare and contrast different things. A good way to practice collating those different ideas. So we'll start off with what's similar between them. So both of these structures are giant because we've got many atoms here that are being bonded together. And this in turn means that they both have high melting points and high boiling points, because it takes a lot of energy to break the bonds between these atoms. Now the bonding in each of these diagrams is covalent, and that's because we are bonding between non-metal atoms, and so we are sharing electrons. However, you can see that graphite has layers, and this means that it is soft because those layers can slide. Whereas the diamond structure is very rigid, and this makes it very hard. So diamond is used a lot in tools to cut because it is a very hard material, so it can be used to cut other materials. You will notice with graphite, each carbon forms 3 bonds, whereas in diamond, each carbon forms 4 bonds. With the 4th electron, this becomes delocalized, and therefore graphite can conduct electricity. Whereas our diamond, having 4 bonds, there is no delocalization and therefore cannot conduct electricity, as those electrons are shared between those 2 atoms. These dotted lines between the graphite layers are weak intermolecular forces, and it's those that are being overcome which allows those layers to slide over one another, making it very soft and making graphite useful in uses such as lubricants, but also pencils. So when we write in pencil on a paper, the layers of graphite are sliding off onto the paper there. So storyboards can be really useful to show methods and help us remember the different processes that are happening in methods. So let's take, for example, our making copper sulfate crystals, and in our question we would normally be given what's been used in order to make copper sulfate. So let's say that it is copper oxide and sulfuric acid. So copper oxide is a base which is insoluble, and therefore we're going to need to remove this by filtering. And because it's easy to remove our base, we're also going to make sure that this is in excess, and so we're going to have a fixed volume of our sulfuric acid. So first things first would be to measure using a measuring cylinder. Say 15 centimetres cubed of our acid, and we could then pour this into whatever we're going to be making this in. Often we do this in a boiling tube. So transfer the acid to a boiling tube. We then use a spatula to add about 2 grams of copper oxide powder. And then we might stir it using a glass rod to make sure that we are adding in excess. And so we then need to remove that excess, and the way we do that is through filtering. So we've got a filter funnel for our filter paper, which is then going to collect that excess copper oxide there, whilst the remainder will then drip into our conical flask, where we can collect our copper sulfate solution. We would then transfer that solution into an evaporating basin. Which we would then heat using Bunsen burner and setting it on a clay pot triangle. And so we heat it until the point of crystallization. So that's the point at which our crystals begin to form, but we don't want to overheat it, or otherwise we won't get our hydrous copper sulfate. We would instead get our anhydrous. But we can then leave to evaporate any remaining water. By leaving it, say, 24 hours, and we would then get our copper sulfate crystals in that basin. So what we've got there is a storyboard of our method in order to make those copper sulfate crystals. So this is a useful way to map out our different required practical methods, including our images, making sure that we're thinking about what equipment we're using for each of those processes. Flow diagrams can be really useful to help us think about our thought processes that we need to do, and so this can be particularly useful with, say, calculations where we want to make sure that we're hitting all of those steps. So, for example, if we are doing a reacting mass calculation where we are given a mass of substance X, and we need to find the mass of substance Y. What are the steps that we need to do in order to find this? So our first step would be a balanced equation. Often this might be given to us. And then from this balanced equation, we would be able to identify what the ratio between our reactants and our products were using the large numbers in front of the substances. We should then look to determine our MR using the periodic table for the mass of each atom. We can then calculate our amount of X in moles using our equation moles equals mass divided by MR. We can then use this and the ratio to determine amount of Y and then using our MR we can then calculate our mass of Y using moles and MR. So our mass is equal to our moles times our MR. So there are 6 steps for us to be doing our reacting mass calculations. So writing out those steps in a flow diagram can help us to think about the different thought processes that we're having to do for these different types of calculations. It's then really helpful to have these at one side when you're doing these calculations so that you can be doing lots of side-by-side examples following through these steps.